Hi everybody, this is Miss Streets again, and today we are learning how to find the volume of pyramids and cones. This equation is very similar to what we've done in the past, where we need to find the area of the base and the height, but this time we're going to divide that by 3. So our equation for the volume of a regular pyramid is the area of the base times the height divided by 3. Remember, regular means that all the side lengths are the same length. So on this first one, if this side is 40, this side is also 40. So that matters a lot when it comes to finding the area of the base. So just as a reminder, that B stands for the area of the base, and H is the perpendicular height to the base. And you might be like saying, Miss Streets, what in the world are you talking about? Perpendicular to the base. So this right here is our height. It also goes up here to that top point there. So that would be our height. So let's look at our first example. I'm going to kind of erase some of these things I've drawn on here. So the first thing we need to know is the area of the base. Well, since this is a regular pyramid, this base is a square. So 40 times 40 would be our base, which is 1,600. And the height in this problem, they just gave it to us. Our height goes perpendicular from the base up to the very top point of our pyramid. So that is 21 feet. So our volume, we're just going to use these things in our equation. 1,600 times 21, and then we have to divide our answer by 3. And when we do that in our calculator, we get 11,200. And because it would be feet times feet times feet, our units are feet cubed, or feet to the third power. All right, let's look at number 2. They don't have a picture for us, but there is some description here. Find the volume of a right square pyramid, so the base is a square, with a base edge length of 2 and a height of 5. So if we just want to draw the base, the area of the base is going to be 2 times 2, which is 4. They told us the height is 5 feet. So now we're going to just use our volume equation. So volume is 4 times 5, and then we divide the whole thing by 3. So 4 times 5 is 20. And 20 divided by 3 is approximately 6.7, and we are in feet, so cubic feet. Our next one here, where our base is a square again, so we've got the square pyramid. This time they didn't give us the height though. That's part of the problem that we're going to have to figure out. So for now, let's just write over here that the base is 15 times 15, which is 225, and we're going to figure out what the height is. So they gave us the slant height is 15, but we need to know the height of the entire pyramid. So if this whole length was 15, we know this side right here is half of that, so that's 7.5. Let's draw this right triangle out to the side. We said that this was 7.5, and this is 15. That's our slant height, but we need to know the height of the entire triangle. And again, we said that would be a perpendicular height, so that's 90 degrees. So we can use the Pythagorean theorem to solve for the height of the pyramid. So h squared plus 7.5 squared is 15 squared. We solve this for h, and we get h is 13. So our volume is 225 times 13, and we divide the whole thing by 3. So our volume is 975. And they didn't give us any units, so we could just say units cubed. Our last one here, our base is in the shape of a pentagon, 5 sides. Now they made this a little bit easier for us because they told us this edge is 8, and they told us the apothem is 5.5. So finding the area of this polygon's not too bad for us this time. So the area of our base is 8 times 5.5 divided by 2, because remember that's that triangle, like that. And we're going to have 5 of those triangles, so then we'll multiply that by 5. When we do that, our answer is 110. They also gave us the height of the pyramid in our problem, which is 4.8. So now we can use this all into our volume equation. So our volume is 110 times 4.8, and we divide all of that by 3. And when we do that, we get 176. This time we do have a unit. It's meters, and it's meters cubed. Sorry, I ran out of room a little bit there, so I had to write it up at the top. Just like I've mentioned in the past, when it comes time for your unit test, you will need to be able to name some of these. So let's just talk about the names of these here on the first page. I'll write them in purple because I like to write in purple. So the first one, we said the base was a square. So this is a square pyramid. The same thing for number 2. They told us it's a square pyramid. Number 3, the base is still a square. So this one's also a square pyramid. But number 4 is not a square pyramid because the base on this one is a pentagon. So this one is a pentagonal pyramid. All right, let's look at the next page. Now we've moved on to cones. So we don't need to label all of these. All of these are going to be cones. The general formula for a cone is the same as a pyramid, as in it's the volume is the area of the base times the height divided by 3. But this time our bases are always circles. So we could say B is the area of the base which is a circle. Pi r squared is how we find the area of that. And h is the height of the cone. All right, so let's try out number 5. 5 says to find the volume of the cone. They tell us the height right here is 8 feet, and the radius here is 5 feet. So the area of the base is pi times r squared, or 25 pi. And the height is 8 feet. So the volume is just going to be 25 pi times 8, and then we have to divide the whole thing by 3. So 25 times 8 is 200. So this would be 200 pi divided by 3 feet cubed, or we could put this into our equation and get about 200, or sorry, into our calculator and get about 209.44 feet cubed would be our volume. All right, let's look at number 6. Number 6, we have to kind of work backwards on this one. It says the volume of a cone with a height of 15 centimeters is 500 pi cubic centimeters. Find the radius of the base. So again, we're going to use the volume is pi r squared times the height all divided by 3. So let's fill in any pieces of information we know into this equation. So they tell us the volume is 500 pi, and that's going to equal pi times r squared times the height is 15. Now we want to get r squared by itself, so let's divide both sides by 15 pi. 500 pi divided by 15 pi. Oh, whoops, I forgot to divide by 3. That's really important. Divided by, whoops, here we go, try it one more time. Divided by 3. So the first thing we want to do is to undo this dividing by 3. So let's multiply both sides by 3. That will cancel those out, and I'll have 1500 pi is 15 pi r squared. I just kind of put the 15 back here in front so that I could have the r squared on one side by itself. So I want r squared by itself, so let's divide both sides by 15 pi. So I'm left with 100 is r squared. To unsquare something, remember, you just take the square root of it. So my radius is 10, and the units we're in is centimeters. So the radius is 10 centimeters. All right, let's try number 7. They ask us to find the volume of this cone. Now, the difference in this problem here for number 7 is they don't tell us the height. Remember, the height has to go from the very top all the way to the base. They gave us the slant height, and they gave us the radius. So using the Pythagorean theorem, we can solve for the height. So h squared plus 4 squared is 15 squared. So I'm going to let you solve that. We've done this plenty of times over this year, but the height is going to be approximately 14.5 inches. So now we can find the volume is the area of the base, which is a circle with a radius of 4. So pi times 4 squared times our height, which we said is about 14.5, and then we have to divide the whole thing by 3. When we put this into our calculator, we're going to get the volume is approximately 242.9 cubic inches. And then our last one here, we want to find the volume of the entire solid, which would be the volume of the small cone plus the volume of the big cone. So we're going to have to add those two together. So my total volume is the volume of the small cone plus the volume of the large cone. So the volume of the small cone it's kind of hard to see those on here, but the radius there is 3 and the height is 4. And here, down here, the height is 8. So the volume of the small cone is pi times 3 squared times 4, and then I'll have to divide that by 3. So 3 squared is 9. 9 times 4 is 36. And 36 divided by 3 is 12. So this simplifies to 12 pi. The volume of the large cone is pi times 3 squared times 8 divided by 3. Again, 3 squared is 9, and 9 times 8 is 72. 72 divided by 3 is 24. So this will be 24 pi. So the volume altogether is 12 pi plus 24 pi, which equals 36 pi. And our units are in yards, so this is yards cubed. Or if you wanted to put that in the calculator to approximate it, that would be about 113.1 cubic yards. So that is how we find the volume of pyramids and cones. If you have any questions or you need some help as you're working on your assignment, feel free to find me on a Canvas conference and we can work out some of these problems together. I hope you have a great day.